Let's solve this question. Question number 101. As shown in figure, a cord is wrapped into a cylindrical reel mounted on a fixed frictionless horizontal axle. When does the reel have a greater magnitude of angular acceleration? Now this is a reel, and on this reel, there is a rope, and now this rope is being pulled down. So now what will be the angular acceleration? So there are four options given. When the cord is pulled down with a constant force of 50 Newton, when an object of weight 50 Newton is hung, it is impossible to determine. The angular accelerations in parts A and B are equal. Okay, let's look at this situation. Let's say we have this reel, okay, this cylindrical pulley, disc shaped pulley, and here we have certain mass which we are pulling it down with a certain force. Let's say 2 mg is the force that with which we are pulling this, and this is the mass m. Okay, now this is the first case. Okay, these numbers are just for reference. And now let's say another case where there is again a same mass m, and I am pulling this. Sorry, I'm not pulling this time. I have kept a mass of 2m. Okay, so in which case the angular acceleration will be more? Let's say this is angular acceleration alpha a in this case, and this is alpha b. Which is greater? Or if both of them are equal? So it seems like both of them must be equal, because 2 mg is the force with which you are pulling this, and 2 mg force also will be there here also. You will feel like that. But so let's look at the answer. Okay, so let's go to the next slide and let's find out. Okay, so first thing what we will do, we will take this as 2 mg force. 2 mg force here, and this is mass m. Okay, now let's say this has a radius r. Now let's say the tension developed here is T2 and tension developed here is T1. Note that the tensions are not equal. Pulley is not frictionless. Okay, so this is T1. Okay, now T2, the torque on this pulley, because of the T2 will be T2 times R, which is clockwise, right? So this will be T2 into R, and this is anti-clockwise T1, right? This is anti-clockwise, so that let me call it as minus. So T2R minus T1R is equal to I times alpha. That is the basic form, or that you can write it as T2 minus T1 into R is equal to I alpha. Okay, this is the torque equation. Now here I can write T2 minus T1. Let me call this as, this is a case A, right? So let me call this as alpha A. This also as alpha A. So T2 minus T1 R is equal to mr square by 2, because for disk the moment of inertia is mr square by 2 into alpha A. So this R and this R will cancel. So we have T2 minus T1 is equal to mr alpha A by 2. Okay, so now here what is the acceleration of this mass m? The acceleration of this mass m will be T1 minus mg is equal to m into A of A, right? So T1 we don't know, right? T1 we don't know. So this is T1 minus mg is equal to A can be written as R alpha A. So this is m, right? M into R alpha A. Now T2 is 2 mg. T2 is 2 mg. T2 is 2 mg. Now since T2 is 2 mg, we can find out this. Okay, we can write alpha A. So T2 is 2 mg. So 2 mg minus T1 is equal to mR alpha A by 2, and T1 minus mg is equal to mR alpha A. If I add this, mg 3 by 2 m r alpha A. M and M gets cancelled. Alpha A is equal to 2g by 3r. This is alpha A, 2g by 3. Let's find out alpha B. Alpha B is the case when we are applied 2m mass here. Okay. This is 2m mass. This is m mass. Here the tension is T2. Here the tension is T1. Let's say this is R. The net torque will be T2R minus T1R into I into alpha B. This is the torque equation. And now this one will have certain acceleration. So that will be 2 mg minus T2 is equal to 2 m AB, and T1 minus mg is equal to m into AB. Right? So now we can add this T1 minus T2 plus mg is equal to 3m AB. Now what is T1 minus T2? That will be I alpha B upon R minus I alpha B upon R. So that is minus I alpha B upon R plus mg is equal to 3 MAB. I is equal to mr square by 2. So this is mr square by 2r into alpha b plus mg is equal to 3 MAB. M gets cancelled. This r and r gets cancelled. So this is minus r alpha b upon 2 plus g. This is also r alpha b. So g is equal to 3 r alpha b plus r alpha b by 2. So this one will be 7 r alpha b by 2. So alpha b is equal to 2g by 7. Alpha b comes out to be 2g by 7r. Okay, alpha b is 2g by 7r. And what is alpha a? Alpha is 2g by 3r. Among these two, which is bigger? So we can see this is 2 by 7, right? Sorry, this is 7 by 2. No, not 7 by 2. This is 2 by 7 and this is 2 by 3. Obviously, this is greater. So that means alpha A is greater than alpha B. And alpha A is the acceleration when you pull it with a certain force. So that means when the cord is pulled down with a constant force of 50 Newton, this will be the correct option.